This is 2019 question 3. It claims that this point is on this circle. Very similar to the equation of a line. If I claim the point 2, 3 is on this line here, I replace x with 2 and y with 3. And if it balances, it's on the line. Circles are no different. It's claiming that an x value of -2 and a y value of k is clearly on this line. So here's what we're going to do. We're going to replace x with -2. We're going to replace y with k. And then we're going to multiply it out and get 2 possible values of k. That's going to be 16 when you use your calculator, provided you own one. After all, it is St. Aidan's. Now, then we're going to go for 16 plus, we're going to go k times k is k squared, k times 3 is -3k, -3 times k is -3k, -3 by -3 is +9. Bring over to 65 to come -65 equal to 0. K squared minus 6k, because -3k minus 3k is -6k. You got your 16 and your 9 to get your 25. Your 25 take away your 65 is your -40. And now you're looking pretty good. You're going to factorize this. -40 is your reference number. And you're going to go for argument's sake, a -10 and a +4. So you're going to get k minus 10. K plus 4 equals 0. You're going to get an answer of k equals -4 and k equals 10. Both of these are what are referred to as integers, where they're whole numbers, they're not fractions, and they're not decimals. That is a ridiculously easy part A to start off with, which is a good thing. Now, part B. Now, well, I'm always going to teach people about circles in the first quadrant. It's in the first quadrant this time, okay? So, it's very important that you realize that they have to be the same. So given the circle that has a center of 2, 2, it will hit the x and y axis at the same time. Likewise, if I went for another circle, for argument's sake, let's go for 6, 6. Hoping that's 6, 6. And once again, I draw a circle. You notice that it hits the x and the y axis at the same time. Should give me a second on that last one there. Probably made it just a little bit too big. There we go. Let's try this again. Circle. There we go. It hits at the same time. Right? This means that you're basically your minus g and minus f. If I was to use 2, 2, g would be minus g would be 2 and minus f would be 2. And basically g would be -2 and f would be -2. Because it's in the first quadrant, you can clearly state that the g value equals the f value. And we know that g squared equals f squared equals c when both axes are tangents. Okay, so there's a lot of information you can garner from it knowing that it's in the first quadrant. So you know that g equals f, and you know that g squared equals f squared equals c. So we've gotten a lot of information straight away. Now, what else do we know? We know that S is a circle in the first quadrant. It touches both the x and y axis. No bother. The line 3x minus 4y plus 6 is a tangent to S as shown. Find the equation of S. Okay. So, if I go back a couple of steps, okay, to back where I was earlier, and you can see that, for argument's sake, the radius of this one here that I was talking about earlier is 2. So the radius is 2, the g value is -2, and the f value is -2. So what we can discern from that is that the radius is going to be plus g. Because if g is -2, the radius is +2, because radius can't be negative. So we know it's not 2, 2, or at least we think it's not 2, 2. So here's what we're thinking. We know that g equals f. We know that g squared equals f squared equals c. And we also know that the radius is the opposite sign of g. So we know that radius equals Radius equals minus g, essentially. So the center is minus g minus f, but we know that f equals g because it's going to be like 2, 2 or 3, 2 or something like that. So we know the center is now minus g minus g. We know that the radius is also minus g. Okay, so that makes things a lot easier. We can now use the perpendicular distance formula because we have the equation of a line that is pretty far away from it. So we know that this line here is a very difficult question, by the way, lads. We know that this question here is the radius, okay? So that we have radius equals ax1 plus by1 plus c all over the square root of a squared plus b squared. Okay, but this c is a different c, so we're just going to rub that out for a minute. Okay, so your a value is 3, your b value is minus 4, your c value is 6. It's the perpendicular distance formula to the center of the circle. Your x1 value is minus g, your y1 value is minus g, and actually your r value is also minus g. Because if the radius was 2, if the x coordinate was 2, the y coordinate was 2, then the radius would also be 2. That's why we're sort of like scaling it that way. All right. Next thing we're going to do, we're going to change r with minus g. I actually sort of saw a mistake in the marking scheme here, which was interesting for once. So 3 times x1, x1 is minus g. The y1 value is also minus g. Minus 4 times minus g plus c 6 all over a squared plus b squared, which is 3 squared plus minus 4 squared. Okay, we go again here, we're going to get minus g, and that's going to be 5 on the bottom when you put it all into your calculator. And on top, we're going to get, oh god, it's minus 3g plus 4g, which is going to be g plus 6 over 5. Going to multiply across, you're going to get minus 5g equals g plus 6. Going to square both sides, going to get 25g squared equals g squared plus 12g plus 36. Those of you wondering what happened at home, I squared both sides. Then I'm going to get 24g squared minus 12g plus 36 equals 0. Go and divide both sides by 12. I don't want that smoke. 2g squared minus 1g plus 3 equals 0. I think I made a mistake here. The 36 came over and became a minus. So that should be a minus 36 and a minus 3. The reference number is 2 times 3 is minus 6. Minus 6, you want minus 3 and plus 2 to make the you want minus 3 and plus 2 to make the minus 1 in the middle. You factorize it out, and you're going to get 2g into g plus 1 minus 3 into g plus 1. And then you're just going to get 2g minus 3 into g plus 1 equals 0. You're going to get g equals minus 1. And you're going to get 2g minus 3 equals 0. 2g equals 3. G equals 3 over 2. Now this is the point I have to reread the question to figure out what exactly I've been asked. Find the equation of S. So it has to be the one. It has to be the one where minus g minus f is in the first quadrant. So if I use 3 over 2, I'd have minus 3 over 2. And minus 3 over 2 is not in the first quadrant. So therefore I can rule that answer out. So the only answer I'm concerned about is g equals minus 1. Open. Okay, so therefore I know g equals minus 1. So this would mean that minus g equals 1. So this means it's the point 1, 1. And I also know that the radius is 1. So I can jump straight into the h minus k format because it might be a bit easier for me. You know that h is 1 and k is 1, so it's going to be x minus 1 squared plus y minus 1 squared equals 1 squared for r squared equals 1. And that is the equation of my circle. It was pretty tricky in the end, but we got there, and that is question 3.